For all the hype about AI, have you ever noticed that even the most powerful models feel kind of stuck? Like they're not quite reaching their full potential? Well, you're onto something. There's a quiet revolution happening right now, completely changing how AI thinks from the ground up. Let's dive in.
So here's the big question, right? We've got these gigantic models, some with trillions of parameters, but a lot of the time they're just slow, and they cost an absolute fortune to run. So what gives? What's really holding them back? This quote from one of the research papers just nails it. They describe it as a powerful engine on a narrow country road that never allows it to exit first gear. I mean, just picture that. A Ferrari stuck behind a tractor, forced to crawl along. That is exactly what's happening with AI today. All this incredible power, but it's fundamentally trapped, forced to move forward one tiny, painful step at a time.
And that narrow country road? Well, it has a name: the discrete bottleneck. See, for as long as these models have been around, they've worked by predicting just the very next piece of a word, what's called a token. It's like trying to write a whole book by thinking, okay, what's the next letter? And the next one? And the next? Yeah, you'll get there eventually, but man, is it inefficient?
And thinking in these tiny fragments has some pretty massive real-world costs. We're talking about financial expenses that are just through the roof, a huge energy footprint, and those slow, laggy response times that we've all experienced. Plus, there's this growing fear in the industry that we're about to hit a hard ceiling on how much more powerful these things can actually get. So yeah, that's the essence of what we're calling AI's first gear problem. But here's the good news. A couple of major breakthroughs are basically showing us how to get off that country road and build a superhighway for AI.
Okay, so both of these new solutions are part of a bigger idea called CALM. That stands for Continuous Autoregressive Language Models. Now, you've got two main teams leading the charge. First, you have researchers from WeChat AI and Tsinghua University who are changing the very unit of how an AI thinks. Then, you've got a team from Google and MIT who are changing how much thinking an AI has to do. Let's kick things off with that first approach.
All right, so this first idea is actually super intuitive when you think about it. Instead of this slow, painful process of going token by token by token, what if the AI could just think in entire chunks? Like, what if it could process a whole idea or phrase in one single efficient go?
This is exactly what they're doing with something called next vector prediction. The AI essentially learns to take a whole group of words and compress them down into one single, dense package of meaning. You can think of this package, a vector, as a rich numerical fingerprint for an entire idea. So now, instead of predicting the next tiny word part, it's predicting the next whole idea. It's taking these huge, meaningful leaps in its thinking process.
So, how does it do this? Well, the magic ingredient is a clever bit of tech called an autoencoder. It's a three-step dance. First, you feed it a chunk of text, say 4 words. Then, the encoder part of the system does its job and squishes those 4 words down into that one single powerful vector. And here's the cool part. The decoder then takes only that vector and perfectly reconstructs the original 4 words, proving that all the meaning was captured. And get this, how well does it actually work? Incredibly well. The research shows that when you compress 4 tokens down into one vector, you can reconstruct them with over 99.9% accuracy. I mean, that's not some fuzzy, low-quality approximation. It's practically perfect. This proves the whole idea isn't just a cool theory. It's a super effective way to do things. Okay, so that's the thinking in bigger chunks approach. Now let's switch gears and look at the second big idea, this one from the folks at Google and MIT. Their angle is a little different. It's not about taking bigger steps. It's about being smart enough to know when you can just stop walking altogether.
They're calling it adaptive compute. And honestly, it's just common sense. Think about how you think. You don't put the same amount of brain power into answering what's 2 plus 2 as you do into solving a complex physics problem, right? Well, this approach teaches the AI to do the exact same thing. If the task is easy, it learns to take a shortcut and just exit early. No need to overthink it. But how does it know when to stop? Well, it has a few clever little self-checks. First, it asks itself, how confident am I in this answer? It also checks if its internal thought process is still changing much from step to step. And my favorite part? It has a tiny little sidekick model whose entire job is just to predict, hey, is the answer we have now good enough to be the final one? And the results are just wild. Take a task like summarizing a document. A normal model might have, say, 8 layers of processing it has to go through. With adaptive compute, it can often get the job done after just 3 or 4 layers and then just stops. That results in a speed up of up to 3.6 times. That's a huge, huge boost in efficiency, all from just teaching the AI not to waste time overthinking simple problems.
Okay, so we have these two really cool, really powerful techniques, thinking in chunks and knowing when to take a shortcut. But what does this actually mean for us, in the real world? Where is this calm technology making a real splash today?
The answer, and this might surprise you, is audio. Generating realistic audio, things like speech and music, has always been a massive headache for AI. Why? Because that old token-by-token method is just terrible for sound. It's incredibly inefficient and loses a ton of quality.
Think of it this way. The old method of chopping up audio into discrete tokens is like taking a beautiful, high-fidelity song and saving it as a really crunchy, low-res MP3 file. You just lose so much of the detail. But this new way, using these continuous vectors, that's like working with the original, raw studio master tape. The quality is just on another level. And not only that, it's way faster and can run on much, much smaller models.
And you don't have to take my word for it. The numbers are just jaw-dropping. Take a look at this. The new GMLM model, which uses this continuous approach, cuts the word error rate by more than half compared to the previous best model. More than half. And it does this while being 10 times smaller. That is not an incremental improvement. That is a gigantic leap forward.
And this isn't just about making better-sounding AI voices. The potential here is way bigger. People are using this COM framework to build models that are more culturally aware, that can understand different global contexts instead of just one. They're using it to make sure an AI gives you the same solid answer, whether you're speaking to it in English or French or Japanese. And it's perfect for things like real-time anomaly detection, constantly watching a stream of data and spotting a problem the very instant it happens.
So, let's zoom out. What does all this really mean for the future of AI? Where is this fundamental shift from thinking in tiny fragments to thinking in a continuous flow actually taking us?
Well, the consensus is that it takes us from a reactive AI to a proactive one. Right now, most of our AIs are like co-pilots. They're amazing, but they basically just sit there and wait for us to tell them what to do. But with the incredible efficiency that COM provides, we're heading towards a future of autonomous co-operators. These will be agents that can continuously monitor what's going on and actually take action on their own without waiting for us.
And that entire future, all of that potential, it's all unlocked by this one single fundamental change. Teaching AI to stop thinking in slow, choppy fragments and start thinking in a smooth, continuous, efficient flow.
It's a really profound shift in how we're building intelligence itself. So it leaves you with a big question, doesn't it? If we've finally taken the brakes off and allowed AI to run at its true speed, what kind of problems that we once thought were impossible, things like designing personalized medicine on the fly or accurately modeling climate change in real time, are now, maybe for the first time, actually within our grasp?